Hello guys and welcome to this video. Today we will see how a simple neural network works, using simple terms and examples, so you can understand what happens behind the scenes when you copy and paste code blindly from ChatGPT. The aim of a neural network is to guess something called an output from an input. For example, guess the gender given the height and weight. Guess the price of a house given its size, location, and number of rooms. Guess the animal given the image. So, what is a neural network? It is a mathematical function that learns to map inputs to outputs. It does this through layers of small computational units called neurons. Each neuron takes inputs, multiplies them by weights, adds a bias, and passes the result through an activation function. Did you catch that last phrase? That's the first key element. Let's break it down. Each neuron takes inputs, multiplies them by weights, adds a bias, and passes the result through an activation function. Part 1. Each neuron takes inputs, multiplies them by weights, and adds a bias. Part 2. It passes the result through an activation function. Remember, the input is the height, for example. So the neuron takes the input, multiplies it by the weight, and adds a bias. This input can only be a numerical value, like nothing else. But what about a cat? It's an image, not a number. We'll cover how images, text, or voice are converted into numbers in another video. Now, what are weights and biases? A weight is a numerical value that determines how important each input is. For example, if we want to guess whether a person is male or female and we have age and height as inputs, we'd expect height to have a higher weight and age to have a bias close to 0 as it's not a strong distinguishing feature. A bias is a numerical value that shifts the output up or down. For example, suppose you want a neuron to predict exam score equals 50 plus 10 times hours studied. The plus 50 part is the bias. It represents the base score even if you study 0 hours. Without bias, the model could only predict 0 when you study 0 hours, which isn't realistic. How do we assign these weights and biases? Generally, we don't. They start with random values and then get updated during the training process. Exercise time. Remember that each neuron takes inputs, multiplies them by weights, and adds a bias. With these values, calculate the output of a neuron. Pause the video and do the calculation. The answer is 5.6. A great job. Now the second part of the phrase, and passes the result through an activation function. What is an activation function? It's a function that determines a neuron's output by introducing nonlinearity. Why do we need nonlinearity? Because the real world isn't linear. Without activation, a neuron can only learn straight-line relationships. For example, price rises steadily with house size. With activation, a neuron can learn curves and complex trends. For example, price stays flat for small houses, rises fast for medium ones, then levels off. Here are some common activation functions. Sigmoid, commonly used for spam detection, yes or no. REULU, used for detecting edges in images. Tanh, used for continuous values like temperature changes. Do you need to memorize them? Number, you just need to understand what they do. This is the activation function visually represented in a neuron, applied after calculating the input or raw output of the previous node. Now, let's review. We learned basic architecture, input layer, hidden layers, output layer, weights and biases. The learnable parameters start with random values. Activation functions add nonlinearity. Now take a 30-second break. You earned it. Welcome. Welcome back. Let's move on. What is a forward pass? If you hear forward pass or forward flow, it just means inputs go in, get processed by weights, biases, and activations, and produce an output. In short, input arrow. Process arrow, output. Now, how does a neural network train and correct itself? We said that neural networks start with random weights and biases, so their first predictions are usually far from correct. For example, if we ask the network at an early stage whether smoking is bad, and it said no, it doesn't mean smoking is good, it just means the network is dumb at this stage. So how do we make it better? Through training, where the network gradually improves by learning from its mistakes. Let's look at this training process. Step 1. Forward pass. Make a prediction. Inputs go into the network. Each neuron multiplies inputs by weights, adds bias, and passes the result through an activation function. The network produces an output, which is its current guess for the target. Step 2. Measure the error. For example, if you have $10,000 and I predicted $9,000, that's a better prediction than one that predicts $0 T9, because the second is way off. This difference is called the loss. To know how good or bad the prediction is, we compare it to the true target using a loss function. Think of it as a score for mistakes. High loss to prediction is far from correct to network needs to adjust more. Low loss to prediction is close to network is doing well. It gives the network a direction and magnitude to improve. Another example, true age equals 25. Your guess equals 30, so loss equals 5. Your guess equals 26, so loss equals 1. The smaller the loss, the better. Formally, one of the most common loss functions is mean squared error, MSE. It measures the average squared difference between predicted and true values, penalizing large errors more heavily. For example, predicted equals 13. True equals 10. Loss equals open parenthesis. 13 minus 10 close parenthesis squared equals 9, meaning the network overshot the target by 3 units. The loss of 9 tells it how far off it is. Step 3. Adjust weights and biases. Using the loss, the network updates its weights and biases slightly to reduce future errors. Over many repetitions, the network learns patterns in the data and makes more accurate predictions. To understand how these weights are adjusted, I recommend watching the gradient descent video by 3 Blue 1 Brown, link in the description. Keeps repeating the same process. Predict, then measure error, then adjust, then improve. To summarize, the network starts random, makes mistakes, measures how wrong it is, and adjusts itself. That's how it learns from experience. It's similar to how we learn a new language. We make mistakes, feel embarrassed, and then improve until we become fluent. Here's what we've discussed in Python terms: activation function and forward pass, loss function. Adjusting weights and biases, simplified. And finally, how a neural network works in practice. Collect data, example. We have a dataset with 10,000 patients. Inputs equals symptoms, age, weight, etc. Target equals whether they have diabetes, yes or no. Split the data. Training set, used to teach the network. Test set, used to evaluate performance on unseen data. Train the network. Inputs pass through the network, make predictions, compute loss. Adjust weights using gradient descent, repeat many times. Network learns from experience. Test the network. Feed test data and check predictions. At first, accuracy is low, but after training, the network converges to higher accuracy. The network improves gradually from random guesses to better predictions to accurate outcomes.